Hi, my name is Thomas Kim. In this session, we will learn primality test using Wilson's theorem. About Wilson's theorem, please refer to Wikipedia. For example, this is primality test and this is Wilson's theorem. We are going to use this Wilson's theorem. Also, you can refer to this primality test here. You can find Wilson theorem here. So we are going to use this test because this session continues from our previous video. Please download the sample source code by clicking this link. When download is complete, open the download folder and unzip it and rename the folder Wilson Primality Test Solution, like this. Now copy it, paste it to your working folder, open it using Visual Studio 2015. I am using Visual Studio 2015. Please note that you probably have to watch my previous video about the system environment settings, these videos. Open the solution. Open this. We will rename it. In the Prom view, other windows, property windows, please select this solution. Then in property window, rename it Wilson Primality Test Solution. Then now save it, then it will change. Now click this. Then we will change it. Right click, rename Wilson Test, like this. Save it. Then property, we will also change it Wilson Test. Okay, we change it. Also here, right click, rename Wilson Test. Okay, now right click, reveal the solution. Okay, it built successfully. Control F5. This is our previous state. Close it. Now open it. Since we don't need these things, just delete it. Here. Now we are declaring some variables for p factorial, mpz, p factorial, like this. We declare one, mpz class p minus 1 factorial. This is for p minus 1 factorial, and mpz class mod p. This is for p minus 1 factorial minus 1 mod p. Okay, now declare like this. Now change it to p Then remove this. Then we say p minus 1 factorial p factorial. Then p factorial p. Okay. Now let's compile. Ctrl F7. Okay, it builds successfully. Now refer to from here Wilson's theorem. Wilson's test, a simple but very efficient primality test. Wilson's theorem states that P is prime if and only if. Okay, so we will copy this text here. This is for your reference. Okay, we can fix like this. Save it. At this point, we need to do some mathematics, some algebra here. So we can state P is 0 for mod P. Okay, we will say this is Wilson's theorem, and we will call it equation 1. Then we can also say plus minus 1 x mod P. We let it equation 2. We need then here like this. Then at this side will become P minus 1 equals x mod P. Okay, so if we say in this equation x is minus 1, so we substitute minus 1, x equals minus 1 from equation 2 for x. We substitute minus 1 from equation 2 for x in equation 3. Then we have P minus 1 equals minus 1 mod P. Okay, so we are testing. Instead of we are testing minus 1, we are testing P minus 1. Okay, so we can say P minus 1 factorial equals minus 1 equals P minus 1. Okay, mod P. If and only if, then P is prime. Now this is Wilson's theorem. So we compute the mod here. mod p equals p. Please note that we are computing p minus 1 factorial. This is p minus p1 factorial. Okay, modulo this is p. It is p minus 1 factorial modulo p. Okay, so if mod p equals p minus 1 p is a prime. SDD and there. Else P is not a prime. Save. Now let's run Ctrl F5. Okay, so 1 is prime, so we close it. We are starting with 2. Now Ctrl F5 once again. 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 6 is not prime, 7 is prime, 8 is not prime, 9 is not prime, 10 is not prime, 11 is prime. So it works like this way. 19 is prime, 19 is a prime, 23 is a prime. So you can check like this. Or if we want bigger numbers like this, let's try it. If it works, it will take some time. Okay, so we can test primality like this. I will post the source code in the description section below. Please subscribe to my YouTube channel. Thank you for watching.